let's start it. Let me introduce first.
Okay.
And then you start it. Okay. Good morning, everyone. Today we are very happy to have our distinguished speaker, Emmanuele Spera. He has about 20 years of experience in the automotive industry and working for the IT management, service, sales, business development. Right now, they are currently focusing on startup company, the name called Next Future Transportation. Their project to try to shake the automobile manufacturing industry, try to disrupt the transportation business, and also potentially may change our routine life.
So could you please speak up? We have people on the phone who can't hear.
Oh, okay. Actually, I'm finished. Okay, then let's welcome Emmanuele. Okay?
Thank you.
Okay.
Thank you, everyone. I want to thank you, IBM, for letting me presenting what we are doing now. And yes, we are trying to change the world of transportation. And the title of the presentation is From Dream to Reality. So let's start from the press coverage that we had in the last 6 months. So everyone in the world has been talking about Next, about what we are doing. So we started from a concept, from a raw idea, and this is something that happened 2 weeks ago. And this is the Sheikh of the Emirates that is introducing $1 billion investment for the self-driving cars and to transform the Dubai transportation system to be 25% self-driving for 2030 deadline. And to send the message, he has been using our design, a picture of one of our modules. So he has been doing this without asking any authorization or nothing, but clearly he envisioned in what we're doing the future of transportation. So this is our mission. So we want to evolve the world of transportation. We want to create a physical network, not only vehicle to vehicle, but physically connected vehicle to transform the commuting, the journey, to transform how the masses use the road and how the masses move around the world. So this is what we want to achieve, and this is our driver. So obviously sustainability, efficiency. We don't need any new infrastructure because we are going on the regular road, so using wheels like a car or a bus. We want to unlock the self-driving experience for everybody, not only private owner of Tesla or very expensive car. And we want to create a scalable ecosystem of module. And this is a video from the V2, so it was after the V1. So the whole concept was already here. So on-demand services, on-demand module to commute. This is the first mock-up of the app where you can choose how to commute, how to travel. The key here was to improve the occupancy rate. the new feature was to have this opening in the middle to let people or goods move from one module to another. And this was kind of Pandora's vase, because we discovered that we can deliver services in motion. So this opened the road for a new, brand new market, so on-demand services. For example, you can order your latte and a Starbucks module could eventually connect and deliver the service, the product. This is the comparison with a regular bus. There was this raised platform that is kind of hard to realize. So all the basics were here. So it's on-demand services and pay as you use. So the system is completely scalable, because at every time you don't need to have a full bus going around the town, but you only need the number of the module to fill them. So you don't need to have 10 huge buses in when there is no peak time just to move around 20 people. So this is the video of the V3. So this is the last design. We completely changed it to make it more feasible. So this new design is completely different. So we don't have the raised platform anymore, and the model, it's more like a small bus. The wheels are covered, and the platform is covering the whole area of the model. So there is way much more room inside, and it's technically more easy to build. And I mean, at the end, it's a box, so there is not a very highly innovative design, because it's a box, but it's the whole concept that is completely new here. So this is the team. There's me, Tommaso, who is the inventor of Next, Sri Yaganathan, our CTO, which is here with us today, and we're gonna answer all the questions you have later. And Federico, who is a vehicle engineer, he's in Italy. Dave is a system engineer, he's here in San Jose. And Raman worked for self-driving sensors, and he's here in San Jose too. This is Tommaso, this is what he do, and we'll see this video about his creation. So let's start from the boring current issues with transportation. So we have a huge environmental problem now. So we have $175 billion in fuel cost with the actual transportation system. So I'm talking about only cars.
Is it worldwide or the US number?
So this is the money we could save only in United States if all the cars were Teslas. this is another economic problem, so it's traffic jam. The Bay Area is developing so much in the last years that the traffic congestion is becoming unsustainable. So 121 billion of dollar saved if Next will be adopted. If Next was already here, we could save this.
That's in addition to 175 you already saved?
Sorry?
That's in addition to 175 billion you already saved, or previous slide?
I mean, this is compared with the car. So if you transform all the car in electric, this is what you can save right now. And clearly this is in addition, because if you remove all the taxi, all the buses, and you know them now, you could save 121 billion with Next. So it's in addition. So I'm talking about under-occupied cars and transit.
He's getting rid of the idling mode. That's all that is.
Then we have a social problem. So it's all the time lost being stuck in traffic, or being waiting for mass transit, waiting for a bus arriving, or waiting for a metro. So this is Morgan Stanley telling us it's $422 billion of lost, this case in working hour. And another social problem that now with self-driving car, we have single pod, we have the Google car, and this is not enough to solve the problem right now. So there is very limited comfort and very limited way to interact with other people. So this is a comparison on Next compared to what you can have now in a matter of self-driving or single user pod. So we are not like single user pod, because the single pod, they have to stack together and you usually have 1 to 2 people on each pod, and there is no transfer from one to another. We are not like a minibus, because the minibus, they are not modular. So they can carry a small amount of people, usually in this case is at 10 easy mile. They are golf carts transformed to be small buses. We don't need any new infrastructure, because we don't need a special lane. We don't need to go on different roads. So we can use the actual system, the actual transportation system. So these are the solution if Next was adopted now. So all these numbers are about, for example, no charging time. We have an option for swap in motion for the battery. So there is a module carrying all the full battery that connects to the module with the empty battery, and it can do a swap of the battery, pushing the module. And with the adoption of Next, we have 75% less traffic based onto the modularity of the module of the vehicle. And we have time save, say 90% time save, and this is, I'm talking about self-driving and on-demand module. On the bottom, there is a comparison between cars and the module, and next module, and on next slide I will show you difference compared to a bus. So this is the swapping motion battery. So the module have 100 miles range, but they could have an infinite range based onto the swap in motion capabilities.
Are these lithium-ion batteries or?
Sorry?
Are these lithium-ion batteries?
Yeah, I mean they are same kind of battery used by Teslas, but at the end lithium. Yeah, we don't need. We have a huge amount of space for the battery, so
How
that we
heavy
can
is
say
one
that.
module?
Sorry.
How heavy is one module?
So one module is like a small SUV. So we are talking about 2.3 tons with a maximum of.
Not the whole module, the battery module.
Oh, the battery. So the battery will take around 15% of the weight. Talking about safety, the module has a raised platform. So all the battery, all the mechanism, all the motors, they are all beneath the platform where people are raising. So in case of accident, the impact will be onto the machinery. So this is the same case that we have on buses. Buses, they have a raised platform. And hopefully this will never happen because we would like to operate the module in a complete self-driving environment. So everything is controlled. You have to control everything around you. But in any case, the structure beneath the platform will absorb most of the contact of the shock. So yes, as told before, less traffic, more productivity, and a solution for the charging. So if you talk about dimension of NEXT, it has the length of a Smart, but it's large and tall like a regular bus. So here we are still into the dream side of the project. So we are trying to envision next our solution in comparison on what is available now and what will be made and built in the next year, I'd say 2020, 2030, smart city and everything. So the common mistake is to envision next in the city as we know now. So as you know that the failing part of this is the human part. So the cars driven by human. So when you have to envision this module connecting and disconnecting in the actual road, it's kind of hard to imagine. But if you think about a completely new world, if you think about smart cities, if you think about all the new town that has been built everywhere in the world, where there is a very, very low adoption of private car and private transportation, and huge investment to improve the self-driving transportation, for example, Dubai. Clearly, this kind of module can be used. Talking about the size of the module, this picture is a little bit tricky because you imagine the module to be very small, and imagine that you're gonna have to stack a lot of people in a very small place. Actually, we are building the full-scale prototype, and I can assure you it's a small room on wheel, and it's not for 6 people, it's for 10 people. So it's 6 sitting and 4 standing. So it's a slice of a bus, if you want.
Question is,
Yes, go ahead.
is it aerodynamic? The shape doesn't.
Sorry?
Is it aerodynamic? Design
So,
doesn't.
The
look
shape,
like.
I'll talk about this later, I have a slide. But anyway, this is the shape of a bus. it's not aerodynamic, obviously, it's a box. But you achieve the aerodynamics when you stack more than one module.
But the front is not.
The front is not aerodynamic. It has the same aerodynamics of a bus. Anyway, we are thinking about producing platoon module, but this is only for the long transfer. Platoon module with an aerodynamic shape. So this is the model we're talking about, the Starbucks model connecting and delivering coffee to the passenger. And it could be Starbucks, it could be Apple, it could be someone who decides to showcase their product. Let's say you are commuting, you have to stay 45 minutes on the model to reach your destination. Apple can just ask the passenger, hey, I'm gonna pay your transfer, your commute, if you let me showcase what I'm producing. So you can have the model connecting and then they will show the new laptop, watch, whatever. And yeah, this is the social network. So there is a highly personalization possible for this model, because as soon as you stack more than one together, companies like Google, again Apple, that now are using, for example, private buses, and are engulfing cities, especially in San Francisco. There's a huge problem with those private buses going around and blocking entire street because they have to move people. In this case, you can personalize the model, and you can create your working space inside the model. So highly productivity. We have another solution for goods. So we can have, for example, a UPS module carrying boxes around, and this module, they can connect together, and we have some robotic rails inside that can move only one box. So you can have a redistribution of box among few modules. So there are barcode reader, anything inside, so we can decide and move the box that need to go northbound or southbound. I've seen that UPS now, they're trying to improve, obviously it's their job, try to improve the software to find the best way to move the box and to dispatch what they have to send in the best possible way. But at the end, I see UPS trucks stopping in parking lot, and physically they have to move the boxes one by one. So they usually do this at the beginning of the day, in the middle of the day, and at the end of the day. So yeah, this is part of our patents. These are the moving shelves that actually can move the box from one module to another. So I said before, there is a redistribution of people inside the module. So this is how you can achieve the lower footprint possible. So our competitor is a bus. But a bus, to use it, you need to have the entire bus all the time around to carry people. Doesn't matter if it is peak time or no peak time, you always have 40 feet, 12 meters of bus going around. In our case, the modularity lets us decide how many modules you need on each time. So you will have more module in a peak time and less module no peak time. So here we are taking 50 people, and we can use 8 module, 1 bus, 10 car. Assume that all the cars are full with 5 passengers, which is really not the case in the States. Or you can have 50 single-use pods. So the footprint, the bus has the best footprint, but the bus is absolutely no modular. And obviously the cost for passenger is higher in the bus, because you have to pay for the driver, you have to pay for the bus to going around empty. So municipality has to pay a lot of money, and they cannot decide the length of the bus. So this is everything we can offer: self-driving, modularity, open space, and optimization for logistics, the battery swap, and on-demand services, and in-motion redistribution of people to improve the occupancy rate. Self-driving car, you only have the self-driving. Pods, you only have the modularity. With self-driving bus, they are not available yet, you have the self-driving and you have the open space inside, obviously. And the price is completely in a disadvantage for the bus, because the buses are very, very expensive. The new full electric Proterra bus is $600,000 for one bus. In our case, we would like to sell each module. We'll have to have price for each module for $35,000. So it's the same price of the Tesla Model 3. Yeah, say 50. I mean, 35,000 in a full production. Sorry?
5 minutes.
Oh, 5 minutes. So this is a competitor comparison for self-driving car, modular pod, and self-driving bus. And this is the cost on the left and the traffic footprint on your right. So next is the cheaper option, and it has the comparable footprint to the self-driving bus, if the self-driving bus is full, obviously. So these are the comparison in the rush hour. We have competitor with self-driving or pool share taxi, could be Uber or Lyft, self-driving bus, and next. So the modularity helps us in every case, so in rush, medium, or low, because if you see, next has the full occupancy rate in any case, but you will have, based on the modularity, you will have more module or less module. The self-driving bus, you will have each time the full bus here. It doesn't matter if the bus is full or is empty, the bus will still be here, compared to a next where you will have only one module to drive around some people. This is the travel planner app. We have this app you can actually use, you can summon the module, but obviously the module is not here yet. And you can choose on how you want to commute and what kind of services you can have. And it gives you a projected price on what you are choosing. There's another video here.
Next cloud-based platform is easy accessible as a mobile app. I can select the destination, but I can also select how to travel and minimize the price. Or decide with whom I want to travel.
Yes.
and finally decide what services I want to enjoy. So the model with the ordered service will reach me on the go. The QR code generated is the key to enter the model.
Yeah, this is one of the options. You have a QR code. You just show it to the camera of the model. The door will open and you use the model. So here we have the Bay Area case. So now, for example, you have 1,000 cars driving northbound from Mountain View, and you will have 1,000 cars with one passenger that will actually reach San Francisco, at the end trying to reach San Francisco, and you will have to park them and to move them around the town. In our case, let's say that you need to move 1,000 people. You will have 1,000 or less module picking up people around. The module will connect onto the 101 during the commute, and people will have to move onto the front module to fill them. And each person will have to move on a different module based on what area of San Francisco they will have to reach. So at the end, we can say that only 10% of the module will actually enter the city. So only with this adoption you can have an 85% cutoff of the traffic. 85%. And this is the app, and give it distance, trip time, estimated fare for the simple commute. And as said before, this is pay as you use. I have a lot of people asking me, if I don't want to move, what happens if I want to stay on my seat? Or elderly people, they don't want to move. People on wheelchair. It said, it doesn't matter if you want to move or no. You will reach your destination anyway. The problem here is that you will probably pay more, and it will take more time to reach the destination just because you didn't move from your seat. So I'm sure that 90% of the people that can move, that can stand up and move, they will probably move because they will pay less and they will reach the destination faster. Talking about software that take care of the module, we are not competing on, for example, with Google for the self-driving software. Now there are a lot of companies working on the self-driving software, and they are investing billions of dollars on this, and we are not a competitor for them. We are the final user. We are their customer. We are the one that want to move masses using not our self-driving software, but the best self-driving software available. And what we are working on is on the very specific piece of software that needs to operate our model. In this case, these are the algorithms to decide when and where and why our model needs to connect. So in this case, we have two modules. They are going in two different places, and here there is a software that will tell the module, join, connect, and do the commute together. So the first part is the when they are not connected, then the model will couple, and then they will disconnect in a certain point. So this is the software trying to find the optimal timing to connect the module. This is our business strategy. So we have human driving period, which could be from now, from the next year, where you have the module with actually a driver inside. So let's say that municipalities, they want to adopt our system. They don't have to rely on not legal and not already safe self-driving software. They can decide each time how many modules they want to deploy. So in peak time, they can have a large number of modules. In no peak time, a small amount of module. And there will be a driver driving the module. Then the module can be upgraded with self-driving software, and they can be sold to everyone who can afford to buy 35,000 module. So if you want to be in the transportation business, you don't need to buy a bus. You just need to buy a small module. So you can use your module as if it was your car, and when you're not using, instead of having an asset into your driver, you can let the module go and it will make money for you, like you have your personal Uber driver. In 2021, there could be a complete self-driving environment in some cities. At this time, you can adopt on-demand services because you are working in a full autonomous driving ecosystem, and there is a large amount of revenue for this because you have all the services. So these are all the business scenarios for next. So this is on the public transportation scenarios, where we can work with the public transportation agency, and we can be the one that take care of the management of the module to move the masses. Then this is a personal scenario where normal people can decide to own a module. They can decide to create their own RV module, so they can have a module with a kitchen, restroom, and bedroom. And then there is a company's scenarios, again thinking about Google, Apple. They can have their own private fleet of module. They can decide how to use them, how to personalize them. So next can be can have an operability in all the three scenarios. So these are our clients. We like to start from public transportation, private, and then private companies. So we started from dream, and this is the reality. So this is the full-scale prototype that I'm building into my driveway. And you have the wheels, everything. And from yesterday, we also have a rooftop. And it's 4 independent suspension and 4 steering wheels. And in this case, we'll have 2 motors in the front, and the motors will be inside the module. So this is this all. Now we have we filed for our international patent, and these are the first drawings. So you see the connecting part here, and the battery. You don't see the battery. These are the battery, and stay on the middle of the chassis. So the whole weight is very low on the ground, and they can be extracted from the back of the module. So thank you everybody. I hope I've been clear enough. And please, if you have any question, I'll try to answer with the help of Sridhar if you if you want to intervene.
You said earlier in the talk that there wasn't any need for new infrastructure. You're using existing infrastructure. But that's not totally true from what you showed us.
I mean, for your system to be 100% effective, you're going to need dedicated next lanes.
You're gonna need, sorry?
Dedicated lanes for the next pods. I mean, you gave the example of 101 going to San Francisco. So imagine you have a train of pods, like 6 or 7 pods, and then you've got three or four more coming on. If there's private vehicles in the HOV lane, you won't be able to connect.
Exactly.
How do you get around that problem?
Let me answer that. Not necessary, actually. So if you think about it, a connected set of next pods is nothing but a bus, right? So when they are together, they are no different than a bus. The length will be approximately the same. But we can also conceive that they could be longer, just like you have big trailers that exist on the freeways today. In terms of interconnection, this is no different than two cars actually fishtailing to each other and then connecting up. So we actually believe there is no need for additional infrastructure, but certainly dedicated express lanes are coming in many parts of the world, where they say this is a specific HOV lane or it's a bus-only lane, etc. So it would help the next proposition, but it's not required. And the net aggregate of what we are proposing is that, like Emmanuele said, we have an 85% reduction because the occupancy rate dramatically increases during commute time, and as a consequence, our freeways will get less congested. So we do not anticipate that as a requirement.
Question. Say some 1,000 people from San Jose want to go up north, but they want to get up various places like Sunnyvale or Mountain View, Redwood City.
Sure.
How do you plan on combining all these and exiting and dropping at their location?
I think our solution suggested it, but basically think of it as we have a first mile, middle segment, and a last mile problem, right? In commuting in general, we are all in different houses. We all go to different office environments, but generally the middle segment, whether it's 280, 101, or whatever freeway of choice in your part of the world, is a common part, right? Cars solve for the first and the last mile problem. They are great at getting you out of the house, they are great at getting you to work, but they are horrible in the middle segment. Buses and metros, etc. are great for the middle segment, but they are horrible in the ends. What we do is to solve for both. So we have a circulating set of next modules near in the vicinity of your home. So like he showed, you dial up next, it comes by, picks you up, picks your neighbor up. You might be going to different offices, different workplaces, and it doesn't matter whether you're going to Saratoga or Santa Clara or where have you. It'll pick you up, it'll get you to a staging point. In phase one of what we propose, the staging point is a physical place where it'll, just like a rest stop, it'll stage the accretion of the buses. And there'll be more circulating modules, but as Emmanuele said, you'll compact the bus train that is being formed. That bus train now goes up 101 or 280, and then as it gets towards San Francisco, it starts suggesting, asking you to move to the right module. So move to module 2, move to module 3, etc. Now each module is now specific to a location. It goes to the downtown San Francisco, it goes to Berkeley or wherever you have, right? So that way we have solved for the totality, the optimization of the commute. And at all times, these modules have been filled up to capacity, right? So we have eliminated a ton of traffic in the middle segment, but we have given personalized, customized service at both ends.
So assuming the passenger will move from module to module.
Yeah, but think of it, right? It's each module is only a big, right? And it's like walking the length of a bus in order to get off or get on. So it's not once the doors open up, there's no complexity to moving between the modules.
Yeah. Shouldn't be a problem, but that's a requirement.
That's right.
So on a related note to that last question, at least in phase one of this project, you envision that there will be something like 2 redistributions of passengers for a typical passenger on their trip? And
There could be, but in phase one it may be that you have just 2 modules connecting, and it's say San Jose or it's say Saratoga or whatever, to simplify the logistics of people movement internally until you get the right kind of levels of adoption, right? As adoption increases, now you have to solve for all this. Okay, make sure everyone who is going to Saratoga moves to the module of relevance, right? But initially at low volumes, you would say 2 of these modules are going to Saratoga, 2 are going to Santa Clara, etc. You can accrete in that way initially. In phase one, we're also thinking that we will have driver-based modules rather than driverless modules. And that has to do much more with regulation, society acceptance and those kinds of things. We do not see that as a technology problem, We certainly anticipate that in time, autonomous vehicles are going to be far safer than human-driven vehicles. And, but certainly we need societal acceptance of that.
So every module will have a steering wheel and driver in the
Not
beginning?
steering wheel, but drive-by-wire, right?
So how does he exit? Like somebody, like in the same example, people are going towards northbound, and somebody want to get off of San Jose Airport. So the last module will be detached, and he will have to steer out, right?
So, in the driver-driven version of it, every module has a driver.
That's what I was
Right.
asking. Yeah.
So, but certainly the central segment can have a single driver for multiple modules. But as you detach, you would have the local modular ring pick up the people that are going to be taken locally.
Oh, I have to get off and get in another module.
Maybe,
Okay.
but ideally, in that driver-driven case, the driver would be there.
Okay.
These drivers come with the module, or are they passengers?
You ask a different kind of question, right? Who takes the risk of driving people around? So,
No, I mean, if you take one of these things, do you have to drive it, or does it come with a driver like a bus? That's
And employees.
so
have
it
some-
has to do with the phasing of this issue, right? What I'm saying is, if you put your mind to 5 years hence, there are no drivers. The modules are autonomous. But societal acceptance of that is not yet there, and regulation is not yet there, right? We are just now talking about autonomous driving for owner-driven cars, where whose responsibility it is? Is it Tesla's? Is it the insurance company will accept your ability to let the car go on itself, or will society accept the damage, right? So those are unresolved issues. When you're talking about accretion of this, multiple modules coming together like a transit system, does the transit system take the risk, right? So we have not, as a society, we have not solved for these issues. Emmanuele and I are part of the smart city initiatives. So we were at San Francisco, earlier this week, and they're talking about redefining the complete transit system for San Francisco, as is Austin, as is Pittsburgh, and so on. Now, these solutions are all advocating for comprehensive change of government regulation and change of mass transit systems. We are not there yet, right? We are changing as we speak. We are changing the wheels of the plane, engine of the plane as we are flying in terms of transit, but we are not there. It's more regulatory than and acceptance than it is technology.